Hi, friends. Welcome again to another episode of Beyond the Clouds, Edge to Edge Transformation. And the kind of things we are doing today take a lot of energy, a lot of power. There was a time when there was a single processor was enough. Today, in a typical AI system, you could have thousands and thousands. And to be able to optimize that, it's really not easy. And I got to know Dr. Norman Chang when he was doing these amazing startups like Apache and brought together many different initiatives and created many standards that today have made it possible to have engines for artificial intelligence, for metaverse, and many other applications. So, Norman, tell us a little bit about you and how did you get into all these things?
Yeah, I'm very glad to be here, and thanks for having me. That I grew up in Taiwan and studied 1 year at National Taiwan University, and then my family emigrated into US. So I served 2 years army at Taiwan before I follow their footsteps and come to California. So in the first 2 years, I studied at Pasadena City College, and before transferring to UC Berkeley, the EECS. And I'm lucky that I can study at UC Berkeley, EECS from Bachelor, Master in 1987, and then got my Ph.D. in 1990. So at that time, very interested in that AI ML is pretty hard because of the expert system. So my thesis was on application of machine learning, or at that time called artificial intelligence for process monitoring and diagnosis. Using the Bayesian reasoning, the case-based reasoning, and also the real-time monitoring. So you can see that at that time is pretty much the first or two the researchers that focusing on the semiconductor process monitoring diagnosis in the equipment modeling area. So that was pretty early. At that time, the kind of a neural network we are using is like 200 neurons, very, very small. And that's why that if you look at the progress today at semiconductor using the AI ML everywhere, it's amazing for the progress after so many years. So after I graduated from Berkeley and joined HP Labs, HP Labs at that time has an AI lab in 1990. And but after 6 months, the AI lab was decommissioned because of the entering into the AI winter at that time in 1990 for quite a few years. So changed my focus at that time to semiconductor and also the signal integrity, power integrity, starting on the PC board, and then moving to the on-chip, the chip signal integrity, power integrity, thermal integrity. So from 1992 to 2000, now we study a lot of effects. And the reason is that HP at that time has a VLIW team at Fort Collins. So we got to visit them every 3 months to Fort Collins and to listen to their problems in the cloud tree, including the need of the inductance and for the static IR drop we are building. So we are building all kinds of tools with a group. And I was a project leader working on the power integrity, static IR drop, and a little bit on thermal and the signal integrity, including the inductance. And so at that time that we got a book with Shen Ling and a couple of professors that on the interconnect synthesis and analysis, including the inductance. So that was pretty early. So at that time, the culture of HP Labs is that there are so many startups coming from our colleagues. And people have a start on the circuit design, on the processor design, and also on the EDA area. And so the culture is that at that time, the group that I'm working with every day, that we just brainstorming what kind of stuff we want to do at that time. So we think about all kinds of ideas and then study which idea may go a long way. So at the end, near 2001, now we came out, maybe the dynamic IR drop is one area that haven't been explored yet. because at that time the Simplex just acquired by Cadence, and there's a need to consider the inductance. And you know that inductance is a very dynamic IR impact for the chip. So we thought that dynamic IR drop would be a very good topic to have a company with. And that's why with the co-founders, with Andrew Yan, who has a lot of business experience and also very extremely good technically. And then with Shen Ning, that in our same group, that we started this company, and with a couple other folks from HP Labs on the Apache Design Solutions, a 2001. And after we started the company, that we look at, we build the static IR drop and the dynamic IR drop. The inductance turns out that it's not a major concern for customers. The inductance a little bit early for the 90 nanometer design, even though some of the design is reaching 1 gigahertz. However, they have a big need on the different scenarios in terms of the dynamic IR drop. That's why we came out the vectorless dynamic technique that turns out to be very important. And also at that time, there's no dynamic waveform library in the .lit. And so we need to come out using the Apache Power Library and do the cell calculation ourselves for the dynamic waveform as a source of the current in the VDD and the VSS network. So that was very interesting. And luckily, that a company got acquired 2011 by Ansys. And since then, I've been staying there. We have a more than 4 times growth compared to 2011's revenue. And since then, you can look at the industry that they are looking at 2 major advancements and 2 major needs from customers. One is 3D IC with a heterogeneous integration. And the other one is the application of the machine learning in all the areas, right? Including the power integrity, thermal integrity, signal integrity, and ESD and security area. And so we can see that there are 2 big pushes for the recent couple of years. One on the 3D IC and the other one on the machine learning. And maybe we can talk a little bit more about these 2 areas.
Wow, Norman, it's amazing. You were way ahead of time. I remember all through the 90s, thinking about power, signal integrity, EMIR, and all was like an afterthought. And today, you cannot even imagine taping out at the high end for smartphones or for many, many devices. You cannot even imagine taping out without all these things. How was it received when you started Apache? How did people respond at that time?
So at that time, because dynamic IR drop was not seen by people, right? So people were skeptical that is there really a dynamic problem? And why don't you run with a 3x power? When you do the sign off for the static IR drop, you can just increase the power by 3 times, and maybe that will cover the dynamic effect. And so our reasoning to customers at that time is that if you look at a localized dynamic effect, even you increase by 3 times, sometimes you will miss the dynamic hotspot. We gradually convince customers that dynamic IR drop is kind of important, and they need to look at this problem. And if you look at now, that dynamic IR drop that has to be run, because you cannot just run a static IR drop for the C4 bomb design. The static IR drop maybe just a 2%, 3%, but the dynamic IR drop can give you the localized drop all the way to 15%, 20%. And that's why people need to fix a problem that before the tape out for the potential dynamic hotspot. And this is even becoming more severe for the 3D IC, because 3D IC, you have a different microbump connection with the interposer, TSV, different places. And you really don't know where is the current flow, right, to supply the charge to the capacitors in the 3D IC for the different chiplet in 3D IC. And so for the 3D IC, concurrent run of the dynamic IR drop is becoming very important. You need to consider all the chiplet at the same time. Another major issue related to the dynamic IR drop is the thermal. So if you look at a 3D IC, particularly for the vertically stacked dies, you have several dies stacked up together. And for the center of the die, in terms of the thermal mitigation, would be very difficult. For example, like TSMC, SOIC, system on integrated circuit. In order to solve the thermal mitigation problem in 3D IC, yeah, you really need to look at the vertical thermal coupling in addition to the horizontal thermal coupling. But how did you handle the vertical thermal coupling? Because in terms of the number of chiplet in 3D IC, it can be more than 10 chiplet, 15 chiplet, or 20 chiplet. Look at the AMD design or Intel design, and many other companies, or the NVIDIA design. And therefore, that to solve the large scale 3D IC, that a lot of tricks that need to be applied in order to run through large scale 3D IC involving many chiplets.
We always have some new problems to solve. We'll never get bored, I guess, in our
Yes,
industry.
that's a blessing. Yeah.
It is a blessing. And I remember you said when you started working on artificial intelligence during your PhD program, 200 neurons was like just about cutting edge. Today, it's a hugely different problem. Do you see that scale up in terms of neural networks, which we need in order to solve the complex problems people are looking at in AI today? Do you think the scale up will continue? And if so, what are the challenges to make that happen?
Yeah, the scaling definitely will continue. And if you look at the larger foundation model, right, for the LLM, the number of parameters for GPT-4, for example, is more than 1.7 trillion parameters. And maybe for the general common foundational model for LLM, the number of parameters will continue to increase. But there's a very nice trend that there are so many startups at Silicon Valley working on the different applications of LLM in different areas. If we look at the semiconductor area or the chip design area, you can build a domain specific or domain adaptable the LLM model for different domains. And for example, for semiconductor domains, that you can build a specific LLM considering all the knowledge from the semiconductor processing materials and also the design process. And you may even separate out several LLM, one for the chip design, such as the one announced by NVIDIA, the chip NeMo. So chip NeMo, they use a lot of knowledges internal to NVIDIA about all the chip design knowledges and circuit design techniques. So they can build a NVIDIA specific LLM adaptable LLM model for their circuit designers. And similarly, like we can build one for semiconductor processing as well. And so you can see this trend for the large scale common large language model, you will continue to increase, including the graphics handling, image handling, and for different kind of applications. And for the domain specific, that we'll see a smaller model, but it's very comprehensive and complete for different smaller scale of the domains, such as the domain for the EDA. So in terms of LLM, if we look at Ansys, we are working on a couple of applications as well. We are working on the LLM application started with Ansys GPT. So Ansys GPT is using the knowledge in the public, including more than 300 YouTube videos and also the hundreds of the courses that are public and more than 10,000 knowledge articles. So we, based on this knowledge, we train the Ansys GPT based on the GPT 4.0. And so we can provide the 24/7 support to customers. Every day we got 1,000 questions from customers worldwide. And for every one of the questions previously has to be answered by AE, right? And that's just take too much time. So if we can build an Ansys GPT automatically provide an answer to the first round of the questions coming from customers. And the more knowledge we put in and the more complete the knowledge we put in, that will save even more time for us. So that's the first application. The second application we are looking at internally is the code generation. So we want to build, for example, some of the tools that we have, including the Ansys Mechanical has a MAPDL Python coding. And also for the Red Hat SC, that we support a code using the MapReduce in the Python environment. We also have a Ansys for the Python code coming from the open source. So in order to help customers to write this MAPDL based on Python, and also for the Red Hat SC applications based on the Python for the PyCscape, and we can build the code generation. We can fine-tune the model based on the GPT 3.5 or based on the Llama 2, and to train a model using hundreds or thousands of the scripts as a base. And then if we are able to generate the code, and we can save the customers a lot of time, right? They just describe the question in natural language, and then we can use the spatially trained LLM model to generate a code automatically for them, and saving a lot of time to develop the code, and also asking our AE to develop some specialized code for them.
Yeah, we are living in exciting times. Now, when I use, and I'm a frequent user of ChatGPT 3.5, ChatGPT 4, but as you know, when you're using a very large model like that, every once in a while it hallucinates or gives answers that are not quite correct. And because I know what I'm asking and have a general idea, I can fix that. When it comes to your customer support line at Ansys, how are you taking care of these kinds of deviations from the correct answer?
That's a very great question. There are two major challenges that when we apply the LLM models. The first one is how did you cut down the hallucination? And if you are using GPT 4.0, you can set a temperature equal to 0, but by setting temperature equal to 0 may not solve the problem. So the other trick we use is that we ask the LLM. Of course, we are using the RAG technique, retrieval augmented generative technique. Everyone is using that. You can put in the knowledge in the prompt together, right? So you can generate the answer that's specific to the information that you provide to LLM. And the other technique that we can use is that we can ask LLM to provide the references in the answer. And this reference can reference the particular YouTube video, or can reference a certain knowledge article or the courses. And so the customers can double check with the content from the reference and see if anything is still hallucinating. So that's the first question. And the second challenge is that for the complicated question, right? That sometimes customers ask a very tricky and complicated question. And for the complicated question, if you try the GPT 4.0, it can help you to decompose into several easier questions. And once we can decompose into several easier questions, that there are tremendous amount of advantages that we can make use of the resources to solve these multiple easier questions. The first benefit is that you can use a GPT 3.5 instead of a GPT 4.0, because in terms of cost, using the GPT 3.5 is 10x less expensive. And then you can also use Llama 2 to answer the question, which is completely free from the open source. And so once you decompose into several easier questions, or you can use a certain technique that is well published in the literature, such as React, can help you to synthesize more questions and answers as a knowledge. And then after we package several questions and let the LLM generate the final answer, and that will be more comprehensive to the question with the references. So these are the two major challenges. Another challenge we see that, say, for code generation is that if you ask LLM to generate a code generation, it will generate a specific code, right? And there are several constraints that some people may want to put the impose on, is that, is it repeatable? Is this code generated by LLM? Is it repeatable? And there are several techniques that you can use to generate a repeatable answer with a guardrail or with a certain technique that several papers have published on that. And the second question is that the generated answer, is it the optimal answer? Because it always, in terms of the theory of the LLM, it can generate one answer, but it's conversational, right? It's generate one answer, but you cannot guarantee that this answer is the optimal answer. Yeah, so that's another challenge, right? If you want to use it for circuit design, or you want to use for certain applications, including the code generation, how did you create an answer that is optimal, not just one of the answers?
I remember the good old days of synthesis, and we had the same issues. I still remember when Synopsys and other commercial vendors said you can actually synthesize. The first skepticism was, how are you sure it'll be optimal? How are you sure it'll be accurate? And over a period of time, we solved those problems. But now we are going beyond zeros and ones logic, and we're now getting into the domain where there's some amount of subjectivity, where people are asking questions, they're trying to understand. So optimizing is a little more complicated, isn't it, when you're answering
Yes,
questions to customers?
yes.
So
So
what is that?
optimization, yeah, optimization is a big push, right, in the industry that from talking to all the customers. And so a lot of optimization work need to be done, especially for system technological optimization. We are going beyond the DTCO, design technology optimization, in the standard cell level. But now when we go into the 3D IC design, that we need to consider the system technology optimization. If you look at a particular 3D IC design, right, you have hundreds of parameters in terms of the choices of the chiplet orientation. How did you put together the placement of a different chiplet? How did you design the number of interposer layers, and where are you going to put a TSV, the thermal TSV or the signal TSV, and how does it impact the thermal integrity when you satisfy the eye diagram co-optimization? So obviously, it's a multi-dimensional problem. And that's why we acquired a company about 5 years ago. It's called OptisLand. And OptisLand, it has more than 100 customers. It has been heavily used in the construction and mechanical area and the fluent area, but not so much in the electronics and the semiconductor area. So for these 2-3 years, we have been trying to apply in the semiconductor and the design area in terms of the eye diagram co-optimization, material, the design for the thermal mitigation in the chip packages system design. Working with our major customers such as Intel, Samsung. Optimization, definitely, like we see a lot of push and demand from customers, and this is a very challenging issue, very good for university as well. With more than 30 chiplets in the 3D IC, how did you do optimization? Doesn't matter using a reinforcement learning technique or using a neural network, but you have to consider multiple chiplet in the 3D IC design.
It's amazing how optimization in one domain now can be used in others. When we were in the early days of AI, everything was very application specific. Looks like now it is possible to take knowledge from one area and apply it to another. So, as you've been a researcher most of your career, do you see that research is getting augmented with all these LLM and other technologies? Do you think that our research will also speed up over the next few years?
Yes, yeah. So I'm lucky that I'm the chip technologist for the electronic semiconductor and the optics BU. I'm also an Ansys and IEEE Fellow for the EDA applications. And if you look at the directions, the generative AI definitely cause a lot of interest in the academic and also in the industry. In the ICK, maybe half of the papers are machine learning related. And there was a panel that using the large language model application for the EDA and the design. There are more than 100 people attending the panel. So you can see that there are a lot of opportunities in the industry applying the AI ML, including the generative AI. And if you can identify a killer applications, that this is a great time to start a companies working on different applications for our EDA domain, right? In the EDA and the design domain, how do we help our circuit designers and the EDA people in terms of the script generation, automation, diagnosis is another great area that after you seeing the output from the tool, how do you perform the diagnosis to help your customers to speed up using the tool? And if you look at many other areas in the Silicon Valley in terms of the cybersecurity and biology area, psychology area, there are so many startups. So like a gold rusher area now at Silicon Valley. Everything is related to large language model.
Indeed, indeed. In fact, I jumped into the gold rush at the beginning of the year, and I feel like a kid in a candy store. There are so many possibilities.
Yes.
And you've been a researcher in AI for, I think, what, more than 20 years now. Where do you see yourself going? I mean, what keeps you going every morning looking at new problems? Where do you see the most exciting problems that you are going to solve?
Yeah, the first thing in the morning is to play tennis. So I play tennis every morning from
Great.
6 to 7:30, and hopefully there's no early meeting. And after playing tennis, then you feel all the stress are relieved. Then you can think about a new problem to solve. And what interests me the most is that get to work on the new areas. So if you can encounter certain emerging need, such as hardware security for the pre-silicon simulation, such as the faster thermal simulation, some of the essential problems that we need to solve in order to move the industry ahead, and also to help our circuit designers and also the chip designers and the packaging and PC board area as well. That if we can have a little bit of a contribution to help them to do the tape out and the design closure a little bit faster, a little bit earlier, and the physical architecture level is very important, particularly for 3D IC. You have to consider all this mathematics effect right from the beginning. You cannot wait too late, not like a single SoC. And that's why there are a lot of opportunities in the physical architecture level in terms of the power optimization, signal integrity, power integrity, thermal integrity. Everything has to ship left. And how did you use a generative AI to attack all these physical architecture level problems? Yeah, it's a very exciting time to work on all these new and emerging problems.
So Norman, when you and I started in the industry, it was good enough to be an expert in synthesis or verification, simulation, or power or EMIR. Today, that's not possible. So when I look at young undergraduates, they're concerned, where do I start? There's so much complexity. What advice do you have for people starting off in either in EDA or in the AI? Where should they start? What attitude do they need to have to be successful?
I think all the new graduates, they need to be well versed in the AI ML because it's almost like the fundamental element that you can get to apply in your daily work, right? Doesn't matter what area that you get into. It's a part of the essential knowledge. Then you want to look at the industry as a whole to identify where are the critical problems that people are trying to solve. You start from there. You don't start from that. You get into the new job and you just work on your job. You may get lost for the next 3 to 5 years and you don't know what you are working on from the system perspective. So you want to look back. You always want to look back in the right from the first day you started working, and look at the whole industry in this particular problem you are solving. What are the critical problems that you are trying to solve for the next 3 to 5 years? And then you will be well above the water, that you have a much better sense that what are the critical problems that you want to move around for the next 3 to 5 years or the 5 to 10 years. And then you will see the opportunities. If you are interested in starting up a companies or joining a startup, you can judge if this startup will be successful, and all starting from working on a critical problem that people need in 3 to 5 years.
There are lots of opportunities and there are lots of challenges. And one of the challenges that we all faced starting during the pandemic was the global supply chain. As we know, in the semiconductor industry, it's gone completely global, from the EDA tools to the IP to the foundries and the test and measurement and all those things. Do you think it's going to get more stable over time? And what are the things we can do to make it more stable going forward?
I think we are far away from stable status yet because of the U.S. China relationship, right? So a lot of the supplier got disrupted. Originally, you get a supply every day from China, and now it may be stopped for the rare element, for example. And then the GPU cannot go to China, and the EDA tools we cannot also sell for quite a few companies in China. So this in terms of supply chain, right? For the EDA tools supply, also the material supply. I think is right now is in an unstable status. People need to find the new supplier in the full chain of the supply relationship, and maybe after 1 or 2 years it will become more stable.
We live in a very complex world today. And
Mhm.
since you were an AI researcher when you started your career, and I was also into AI, we had all these dreams, and all we had was tiny neural networks in those days. So, do you think a lot of the dreams you had in those days are coming true now? And what is
Yes,
it that you dream of going forward?
yeah, it's a big surprise, right? At that time, starting with the 200 neurons, and now you are looking at trillions of neurons, and even will go higher and higher in terms of the numbers and the complexity of the system. Maybe we will see new phenomenon coming out when we have a very large scale neural network. What's the new property that will emerge? And that question that we don't know. Yeah, and we were waiting to be seen.
True, true. People worry if systems will get more conscious and will start taking decisions on their own. Which
That's right.
brings me to one of the big concerns that a lot of people have, which is about jobs. With synthesis, it actually created more jobs in the semiconductor industry. So we didn't really have the problem people were worried about. What about now? Because AI is everywhere, it's getting more generalized, much more prolific. It is going to disrupt many jobs, right? Where do you see it going in terms of the future of work?
I think it's a natural evolution. More than 100 years ago, the engine, the motor, right, were invented, and then a lot of people lost job, and electricity and the motor, and that changed the foundation infrastructure of the society. Now with the AI ML, maybe not now, but 10 years, 20 years from now, we will see that there are more and more disruptions, right? We will see the driverless in the vehicle, and we'll see robots coming from Tesla. Maybe that will take care of the senior people and also doing a lot of work in the dangerous places. All those jobs will be replaced by AI and embodied in the robots. And so there are huge potential for the society in terms of the applications of the AI, ML, and robot. So we just need to follow the evolution and see what are the jobs that humans will be doing in the next level.
You worked on many new ideas early on in your career and startups, and now you're continuing to work on many research. Was there one particular thing that you enjoyed the most, that is you are most passionate about in all these different things that you invented and discovered?
Yeah, the most exciting thing is that you identify a new area, and not much research has been done in that new area. And you will be the first couple ones to work in that new area, such as pre-silicon hardware security, for example. And so once you identify this new area, and maybe it will be needed by customers in 2 to 5 years, that will be very exciting.
It's always exciting talking to you, Norman, and I always learn new things. And thank you for making the time to talk. And I would love to see 5 years from now how the same conversation will be different. It'll be a very
Yes.
different world.
Yeah,
So,
yeah.
and to everybody listening out there, we are living in a very complex world. Things are changing at an unprecedented level. They have been changing for I don't know how long, but now it's more visible because everybody's jobs, every part of life is getting affected. So please come forward, talk about where you see it affecting your life, your work, and let's build a future together so that it'll be safer, better, more sustainable. So thanks again, Norman, and I'm learning a lot. And it's amazing to see you do all these startups and now build Ansys into a very powerful multi-physics engine that is going into many different domains.
Yeah, thanks for having me, and it's a great conversation with you for on this so many interesting questions, and also the prediction for the next 5 years that we will never know, because right now the evolution and the change of pace is so much faster than before.